Here we have a calculus problem on finding critical numbers of a function. So there is a function given over here and I have to find critical numbers for this function. Okay, to find critical numbers for a function, first I need to find the first derivative for the given function. Then the first derivative has to be equated to 0 and solve for x. Okay, now let me write the given function as it is. That is f of x equals to x to the power of 3 over 5 times of 4 negative x. Okay, so before I find first derivative for this function, I have to do some simplification on the right side over here. That is, I have to distribute this x to the 3/5 part to this 4 and this negative x. Okay, let me do it. So when I distribute this x to the power 3 over 5 to this 4, then I'm getting 4 times x to the power 3 over 5. Okay, when I distribute this x to the power of 3 over 5 to this negative x, what I need to do is I have to multiply this one and this one. So here the base is x, here also the base is x. Whenever I multiply two terms with the same base, I have to add the exponents. Okay, here we have exponent 3 over 5. Then what is the exponent of this x? Actually, we don't have any exponent for this x. Then we have to assume there is exponent 1. Okay, negative. So now I multiply two terms with the same base. So that is x. So I have to take the base ones and I have to add the exponents 3 over 5 and the exponent over here 1. Okay, now let's simplify this one. F of x equals to 4 times x to the power of 3 over 5 negative x to the power of. Now I have to simplify this one. So for that, we can multiply this integer 1 by the denominator of the fraction 5 over here. Once I'm done with this multiplication, I can take this 5 as a common denominator. Then I'm getting 3 times, 3 positive. This 1 times 5 is just 5 over. Now we can take the 5 as a common denominator. So f of x equals to 4 times x to the power of 3 over 5 negative x to the power of. So when I simplify this one, I'm getting 8, then divided by 5. Okay, that's all the simplification I can do in the given function. So now what I can do is I can find the first derivative of the given function. Okay, here the variable is multiplied by a constant. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant 4 as it is, and I have to find the derivative of variable alone. So to get the derivative of this one, I can use the power rule of derivative. That is, I have to bring this exponent in front of the variable and subtract 1 from the exponent. So now let me bring the exponent 3/5 in front of the variable and subtract 1 from the exponent. Negative, the same thing. I have to apply the power rule to get derivative of this one. That is, first let me bring the exponent in front of the variable. Then I subtract 1 from the exponent. So f prime of x equals to, so here 4 times 3 is 12 over 5 x to the power of. So now we can simplify this one. That is, I have to multiply this integer by this denominator 5. Then I'm getting 3 negative 5 over 5 negative 8 over 5 x to the power. So the same, I have to simplify this one. For that, I have to multiply this integer 1 by the denominator of the fraction. So 8 negative 5 over 5. So f prime of x equals to 12 over 5 times x to the power of negative 2 over 5. When I simplify 3 negative 5, it will become negative 2. Okay, negative 8 over 5 times x to the power. When I simplify this one, I'm getting 3 over 5. Okay, now in this particular term, the x is having negative exponent. So we have to make it to be positive. For that, I have to move this term x to the power of negative 2 over 5 to denominator. So whenever I move a term from numerator to denominator and a denominator to numerator, so its exponent will change its sign. Already it's negative exponent. So our aim is to make it to be positive. So that's why I want to move this term to denominator. Let me do it in the next step. So f prime of x equals to 12 over 5 times x to the power of 2/5 negative 8 times x to the power of 3/5 over 5. Okay, now we have to simplify the stuff over here. So for that, we need to have the same denominator. So here the denominator is 5 times x to the power of 2 over 5, but here we just have 5. So to get the same denominator, what I need to do? I have to multiply both numerator and denominator of the second fraction by this stuff x to the power 2 over 5. Okay, let me multiply both numerator and denominator over here by x to the power of 2 over 5. Okay, now let me continue on the next page. This is the last step we have had on the previous page. Okay, let me continue over here. F prime of x equals to 12 over 5 times x to the power of 2 over 5 negative 8 times. Okay, now let's multiply this one and this one. So here we multiply two terms with the same base x. So whenever we multiply two terms with the same base, we have to take the base ones, that is x ones, and we have to add the exponent 3/5 positive 2/5. So this is a product rule of exponents, and here in denominator 5 times x to the power of 2 over 5, then I'm writing 5 times x to the power of 2 over 5. Okay, now f prime of x equals to, now for both the fractions we have the same denominator, so we can take this 5 times x to the power of 2 or 5 as a common denominator. Okay, let me write it. So 5 times x to the power of 2 or 5. The numerator of the first fraction over here is 12, and whatever sign we have in between the two fractions should be taken as it is. 8 times x to the power of, and here we have addition of two fractions with the same denominator 5. So we can take 5 as a common denominator and we can add the two numerators. So 3 positive 2. So f prime of x equals to 12 negative 8 times x to the power of, so when I simplify this one, I'm getting 5 over 5. So over 5 times x to the power of 2/5. Okay, let me continue over here. F prime of x equals to 12 negative 8 times x to the power of, so 5 over 5 will become 1. So we get 8 times x to the first power. So whenever the exponent is 1, we don't have to mention. So we can leave it and divided by 5 times x to the power of 2/5. Okay, that's all the simplification I can do in the first derivative of the given function, that is f prime of x. Okay, now what I need to do is I have to equate this first derivative to 0, that is f prime of x has to be equated to 0. So when f prime of x equals to 0, the stuff which is equivalent to f prime of x also must be equal to 0. So then I'm getting 12 negative 8x over 5 times x to the power of 2 or 5 equals to 0. Okay, now I multiply both sides by 5 times x to the power of 2/5. Let me multiply the right side by 5 times x to the power of 2/5. So this 5 times x to the power of 2/5 and 5 times x to the power of 2/5 will cancel out. I'm getting 12 negative 8x on the left side. On the right side, when this stuff is multiplied by 0, it will become 0. Okay, now to solve for x, so I add 8x to both sides. When I do so, the negative 8x, positive 8x will cancel out. I'm getting 12 equals to positive 8x. Now I divide both sides by 8. When I divide both sides by 8, this 8 will cancel out. And both 12 and 8 are the greatest common divisor 4. 4 goes into 8 twice and 4 goes into 12 thrice. So we get 3 over 2 equals to x. So now I have equated the first derivative to 0 and solved for x. So I got x equals to 3 over 2. This 3 over 2 is called critical number for the given function. And also we cannot decide only this 3 over 2 is a critical number. So because we have to do one more check. So apart from the critical number what we got over here, so we have to go to the last step of the first derivative. That's in this step. So in this step, we have to verify. So f prime of x becomes undefined for any value of x. So for example, in the expression we have on the right side of f prime of x, if I plug in x equals to 0, what will happen? If I plug in x equals to 0, so the denominator will become 0, then the value of f prime of x will become undefined. So x equals to 0 makes f prime of x becomes undefined. So the value of x which makes f prime of x becomes undefined also has to be considered as critical number. So we get two critical numbers. One is the one we already got it, that is 3 over 2. The other critical number is the value of x which makes f prime of x undefined, so that is 0. So there are two critical numbers for this function. One is 3 over 2 and the other one is 0.